A warm welcome to you, dear students. This is teacher Sharon De Silva, and in this video, we'll study about chapter number 9, Heat. What are the causes of the happenings in the pictures shown below? Observe the pictures carefully. There is a reason why a particular thing is happening in that particular picture. So you have to think about what is the cause of it. Now you have to do some fun activity. You have to rub your palms against each other and put them on your cheeks. What do you feel? My dear students, the pictures which were shown and the activity tells us about some of the properties of heat energy. Now let us study more about heat energy and its properties. Now this particular boy is has some questions. For example, he has questions like, how does the sun's heat reach the earth? Why does the heat of the water boiled decreases slowly once it is taken off the flame? Where does this heat go? I'm sure you too must be having such doubts. Like, why does a cook wrap a cloth around the end of his spoon while stirring the boiling milk? Or why do we hold a steel glass with the help of a handkerchief while drinking hot liquids from it? So let's see, why do all these things happen, or why do we do it? It is due to something known as transfer of heat. When we take a hot object in the vicinity of a cold one, the cold object becomes warm and the hot object becomes cooler. From this, we can infer that heat is transferred from a hot body to a cold body. I'll repeat, when we take a hot object in the vicinity means closer of a cold one, the cold object becomes warm and the hot object becomes cooler. From this, we can infer that heat is transferred from a hot body to a cold body. Transfer of heat means the flow of heat from one place to another. This transfer of heat, my dear students, takes place via three ways. These are called as modes of transfer of heat. And what are these modes of transfer of heat? Conduction, convection, and radiation. These are new words to you. Need not worry, we are going to study about each in detail. I will repeat, the modes of transfer of heat are conduction, convection, and radiation. Let's see what these are. Conduction, over here. Transfer of heat energy through direct contact. If you look at this picture, this person is holding a metal rod and he is heating it with the help of a candle. Now this end of the rod is heated, so it is shown in reddish color. And as it becomes hot, we feel the heat at this end as well. So this type of heat transfer through direct contact means we are touching that particular metal rod and this metal rod is also touching the flame. So this direct contact of transfer of heat is known as conduction. So transfer of heat energy through direct contact is conduction. Now let us see the second one. Transfer of heat from one place, always hot, to another place which is cold by movement of fluids. Now fluids, my dear students, in this case can be liquid and can be gas too, so can be air too. I'll repeat this: transfer of heat from one place to another by movement of fluids is called convection. If you see inside this particular vessel, there is some kind of liquid. Let us assume that this is water and water is being boiled. So, what happens is when heat reaches this water which is at the bottom, it gets heated and it rises up. When it rises up, it pushes the water which is on top. Now, the top water is cooler, it has to go somewhere. When this bottom water goes up, the top water comes down. Same thing happens this side. So, this transfer of heat by movement, you see the fluid inside is moving. So transfer of heat from one place, from hot to cold, by movement of fluids is called as convection. My dear students, this can take place in air too. We will see that a little later. And the third part is radiation. Transfer of heat from one thing, hot, to another, cold, when the things are not in contact to each other. You see this particular picture? Sun's rays reach earth and they heat up the earth's atmosphere. Now, if you know, I'm sure you do know that between the sun and the earth, there is no air. It is vacuum. When there's nothing, it is called as vacuum. So in space, there's vacuum. That means there is no air. So there is no direct contact also between earth and sun. So conduction does not take place. Since there's no air, convection does not take place, but still we feel the heat of the sun's rays. And the reason for that is radiation. So transfer of heat from one thing to another when the things are not in contact is known as radiation. So my dear students, these are three modes of transfer of heat: conduction, remember direct contact; convection, you have to remember movement of fluids; and radiation, no direct contact. Now let us see another picture, two pictures actually. First we are going to look at this particular picture. Look over here. This pan is being heated on the flame. The flame is touching the pan and the pan is being heated. So over here the mode of transfer of heat is conduction. Now look here. Again the pan is being heated on fire, but there is some gap over here. But in this gap, what is present? Air. So the air over here is being heated and that air heats the pan. So this is due to movement of fluids. In this case, the fluid is air. So this is convection. And over here, see, suppose this is my hand and I am feeling the heat which the pan is giving out or the pan is radiating. So this particular mode of transfer of heat is known as radiation. Again over here, now look at this particular picture. Some logs of wood are being burnt and this particular person is heating or is warming up an iron rod or metal rod, and since it is he's touching it and this particular thing is touching the flame, so this is conduction. Now the air over here is being heated and this person is warming or keeping the hands directly on top, so the heated air reaches the person's hands. Just a minute. Okay, the heated air reaches the person's hands and this is convection, but these hands are far away. So the person is feeling the radiating heat, not the direct air. Now here also you may say that teacher, yes, the air over here also can be, but suppose this person is a little far away, so he is feeling that heat. So that is known as radiation. So these are three examples: convection, conduction, radiation. Now let us see each one in detail. Conduction. Now we are going to see a particular experiment. You need not do this. This is just for explanation purpose. So please pay attention. So what do we need for this particular experiment? The apparatus required is bars of stainless steel, aluminium, copper, candle, a burner and some pins. Now what exactly are we supposed to do? Take stainless steel or iron, copper and aluminium bars, each about 30 centimeters long and having the same shape. Apply wax spots with the help of candle at a distance of 2 centimeters from each other on all three bars, and stick a pin at each of these spots so that it is upright. Now insert the ends of all three bars into a flame at the same time. So this is how your apparatus or your uh, this is how the picture looks like. There is a burner over here, Bunsen's burner. This is a tripod stand on which you have three metal strips or three metal rods of the same length but different material. There's stainless steel, there's copper, and there's aluminium. We have stick pins with the help of candle wax. Okay, at 2 centimeters each, and all three are being heated with the help of a burner at the same time. We'll come to this picture a little later. Now let's see what happens. Pins start falling from the end near the burner. It means that transfer of heat takes place from the hot part of the bar to the cold part. This transfer of heat from the hot part of an object to cold is called conduction of heat. Now, my dear students, what happens over here is when we start heating this part, we know that these rods become hot. And as they become hot, they start transferring the heat towards the other ends. And these pins are stuck with the help of candle wax. And we know that wax melts when it is heated. So what happens is when heat reaches this particular pin, the wax melts, and this pin which is over here, it is no longer being held and it falls down. Then heat reaches here, the pin falls down, then this, and finally this. So this is how this particular experiment proves transfer of heat through conduction. Tells us that heat is being transferred this way. Now these are three different rods, my dear students, means three different material is being used. There is a reason for it. Let's see what it is. The pins on copper bar start falling first. The pins on the steel bar fall comparatively late. Now heat is conducted quickly through copper. Conduction of heat through a substance depends on the properties of that substance. Conduction of heat takes place through a solid substance, shows that a medium is required for the conduction of heat. I was telling you about this particular picture. This is an actual representation, but the only thing is, instead of pins, they have placed certain paper, a paper which burns quickly. So what happens is when this is being heated, the heat gets transferred, and this paper, either it is, if it is made up of wax, sometimes thin paper with wax coating on it, it starts melting, and then if too much heat is applied, it can even start charring or burning. So again, different types of rod, you can see the color difference. So different types of rods are being or metal are being used. Next, my dear students, is convection. Now apparatus required is a beaker, potassium permanganate crystals, burner, water, etc. Procedure. Take some water in a beaker, heat the beaker slowly on a gas burner. Drop a few crystals of potassium permanganate into the water. This is how the apparatus looks like. There's a burner, there's a tripod stand, beaker, inside beaker there's some water, and some crystals of potassium permanganate are added to it. So what happens? Let's see. You will see streams of colored water going upwards and coming back to the bottom. Due to potassium permanganate, these magenta colored streams can be identified easily. Now, my dear students, we are heating this water. So, a little before or little earlier in this particular video, I told you about when water or fluid is heated, the hot water or hot liquid rises up and the cold liquid from top comes down. So there are streams of fluid inside the beaker. Now when the liquid is colorless, we cannot see them clearly, but over here we have added crystals of potassium permanganate. It is pinkish magenta colored. So now we can see streams of water rising this way and coming down because of that magenta color. So this shows convection of heat. When heating begins, the water near the bottom becomes warm and its density decreases. As a result, it moves upwards and is replaced by cold water coming from above. Convection can occur in liquid and gaseous substances. Convection needs a medium. In this manner, heat is transferred by the means of currents called convection currents. This process is called convection of heat. My dear students, these are called, this you can see this blue and red colored arrows. These are called as convection currents. So in this case, hot liquid rises up, cold liquid comes down, and this is a continuous cycle. So this is called as convection current. Same way, in the same manner, in the atmosphere also we have convection currents. Due to the sun's rays, the heat or the air becomes warm. In this case, the warm air is on top because the sun is on top. So the warm air, this air becomes hot and it comes down. Now over here closer to the ground the air is cooler. This air then rises or this air comes up. So we have air, cool air sinks and warm air rises, and this is how convection currents take place. You will study more about them in detail in geography. Relation between density and convection. Now over here, the apparatus is a test tube, a piece of ice, wire gauze, burner, candle, etc. Now take some water in a test tube, wrap a piece of ice in a wire gauze and drop it in the test tube. It will sink to the bottom. Now using a test tube holder, hold the test tube at a slant, heat the upper part of the test tube. Stop heating when the water starts boiling. Observe the piece of ice at the bottom. This is how the picture looks like. You have a test tube holder. There's water inside. There's ice wrapped in wire gauze and we are heating it. But you see how the test tube is being held? The test tube is not heated over here. The test tube is heated at this particular position. And the test tube is at a slant position. So the heat does not reach, even though the heat does not reach the ice even though the upper part is heated. The density of water decreases due to heating. Therefore, it cannot sink and the process of convection does not occur. Now what happens is, since we are heating the upper part, the heat does not come reach this particular ice, and the ice does not melt, it stays as it is. Tells us that convection does not take place in this particular part. My dear students, we will stop here. We will study about radiation in the next video. Till then, thank you for watching. Have a nice day.